Okay, so good morning, everyone. Today I'm going to present the computer-aided engineering assignment, and I have been assigned with the problem of analysis of conjugate heat transfer in a channel subjected to constant heat flux at the wall. For this, we'll be using the ANSYS software. So just search Workbench, which is a specific package of the ANSYS software where we will be using the uh, computational fluid dynamics and other parameters to solve the given problem. Sorry. So after opening the Workbench, you will be seeing some panels like this. This one will not appear. Yeah. So it will be something like this. Here there are various analysis system which you want to analyze. So based on your analysis and based on your requirements, you will be selecting a specific one of it. For our particular problem, we will be dealing with fluid flow. So just drag and drop it over this place. After that, you will be getting the various parameters over here, which is geometry, then mesh, setup, solution, and after that results. In the geometry part, you will have to import the geometry which you will be analyzing for the problem. In the meshing part, you will be dividing the geometry into a number of elements and nodes further. In the setup part, you will be giving the boundary conditions, applying the various parameters like laminar flow, the density of the the fluid properties, the material which you are dealing with, all those stuffs. And later on, you will be running the calculations and initializing the part to get the solution and further the results. So for the geometry part, we'll be using the new design modular geometry. So just click over it, and here it will be getting started, starting design modular. So just wait for some time after it opens, and here you will get some panel like this. In this, we have to create a geometry like this one. Here, if you can observe, we have one fluid domain, and two solid domain. And in this passage, the fluid, particularly or fluid, will be flowing. So we have to analyze the flow parameter as the fluid passes through the channel. So we will be creating that geometry. So for that, we you can choose any three of this plane. I'm choosing the XY plane, and in order to have a normal look at it, you can just click at this icon. So it will just give a normal view of it. So after that, we need to create a sketch. Go to just sketching. In the sketching, we'll have to select the rectangle. Just select the rectangle and point it over here and just drag and drop like this. So it will generate a rectangle out of it. Now we need to make sure that the rectangle is symmetric about the horizontal axis for easier analysis purposes. So just go to the constraints. Here you will have one parameter named symmetry. Just click that one, and now we have to select three parameters. The first parameter is the line about which the two edges will be symmetric. So you need to select the horizontal line. I will be selecting the horizontal line as I want these two lines to be symmetric about this line. So I choose first the horizontal line. After that, I choose this and this edges. So it will make sure that this and this line are symmetric about the horizontal line. After that, after making it symmetric, we will go and put in some dimensions. In the dimension part, I am going to make the rectangle 2 meter long and zero point 0.1 meter wide. 0.1 meter wide. So just go to the general section, general dimension. It includes both the horizontal and vertical dimension, so no need to separately select them. In the general section, select the general part and select the edge to which you want to enter the dimension. Just drag and move it upwards. You will get the H1 is H1. It shows the dimension of this line. Here it will get H1 as 51.808 meter. Here we want 2 meters, so we will enter our value as 2 meters. And one more thing, you can also change the unit over here by going to the units, and here you can get a lot of units a lot of units like meter, centimeter, millimeter. I'm dealing with meter over here. If you wish, you can deal with centimeter or millimeter as well. After giving the horizontal dimension, I need to give the vertical dimension. So just drag and move it like this. So here you have to enter the value as zero point 0.1 meters, zero point 0.1 meters. So after giving the dimension, as you can observe, the rectangle has become very small, very small. So if you zoom a bit, you can observe it quite carefully. So this is our okay. So this is the rectangle that we have made. Now we want to create a sketch out of it. Create a sketch out of it so that we can analyze the fluid flowing over this section or channel. So for creating a surface out of this sketch, you have to go to the concepts. In the concept, you will get option surfaces from sketch. What this basically does is that it creates a surface from a given sketch. So if you have the sketch like this, so it will make a surface out of the sketch. Instead of lines, it will make a surface, which is a 2D space, right? So surfaces from sketch, select this one. So here, if you have to choose base object like the sketch from which you want to create the surface. So for the base object, I am going to select my sketch over here. Just click on the sketch, which is this sketch. So after selecting the sketch, click on apply. So it will create the surface out of this sketch. So click apply. Now it has been applied, but as you can see, no sketch is yet being formed. This is because we need to generate this surface. Here you can see a thunderbolt sign, and here this is the generate option. So if you click on the generate part, it will create a nice surface out of the sketch part. Now, our fluid domain. This is our fluid domain. This part is completed. Now we want to create the both the solid domains, both above and below it. So for that part, I am going to create one different sketch, and in that different sketch, I am going to create the solid domains. So for creating a different sketch, I just click on this icon over here, which is just besides the generate option, this icon, as you can see. So click over here, it will create a new sketch. This is our new sketch. So select it and then go to sketching. After selecting the sketch, you go to sketching. So once you go to sketching, now create again two rectangles as we have done it before. Select this point over here, and drag and drop like this. Similarly, in the bottom part also, select this point and drag and drop like this. So after this is our rectangle. Now again, we need to give the dimensions. Just go to the dimensions and give the vertical dimension, this one and this one, and this one is zero point 0.1 meters and zero point 0.1 meters. Okay. So this is zero point 0.1 meters and this one is also zero point 0.1 meters, right? Now, you might be wondering that why I didn't give the horizontal dimension, because I didn't. If you want, I can give the horizontal dimension, as you can see, but it will show a constraint error. Constraint error, like this is new dimension makes model over constraint. It will give a over constraint error because I have already fixed the point, this end point of this rectangle with the end point of this rectangle. So it automatically takes the dimension of this rectangle. So no need to separately define the dimension of that rectangle separately. So we'll just click OK, and this is in red because this one is an error. So we'll just get rid of it by hitting Control Z on our keyboard. So this is our overall overall geometry. Now you also need to create the sketch from these two rectangles, as these are the two solid domains. So you have to create one sketch for this one from this surface from this sketch, and similarly another surface from this sketch. So for creating again surface from the sketch, we will be going to the concept part. Here we have the surfaces from sketch. Select this one and select the sketch. Select the sketch for which you want, from which you want to make the surface. After selecting the sketch, hit on apply and add material as frozen, because we will be adding the material in the later stages of our analysis part. So add frozen. If you add frozen, it will select, it will basically select one material which is different from the fluid channel, which is different from the fluid and fluid domain that we have chosen. uh, Now after adding frozen, just go and hit the generate button. It will generate the various parts. So in the three part bodies, if you observe, you have one surface body, which is the fluid domain. You have another surface body, which is the solid domain, top solid domain, and this is your bottom solid domain. Now let's just rename it for convenience purpose. That will make our analysis part much easier. This is our fluid domain. This one is our, uh, let's just rename it like top one, top one, and this one as our bottom one. Okay, so this is our fluid domain. This is the top wall, and this one is the bottom wall. Now we need to create one part out of this three different parts. Like one part will be including all the three parts. So for that, just select all of them by clicking Shift and uh, left mouse button on your left mouse button. Now just right click and you will be getting one option from new part, form a new part. It will basically create one new part out of these three different parts. So if you click on this one, so it will be creating a new part. It has created a new part. So if you just go here, click on this plus icon, you can see the different parts that it has created another new part. So this whole part includes the three different subparts, basically the fluid domain, the top wall, and the bottom wall. So in the designing is, I think, done. The designing part is done. Now we'll go to the meshing part. Now we'll go to the meshing part. Now you can just close it over here. Yeah, close this. Sorry, sorry. Close this one. So you can observe a tick option besides the geometry part. That means whatever geometry we have made is being successfully imported in the geometry section. Successfully imported in the geometry section. Now, after that, we'll go to the meshing part. Now, right click over it and press edit. So just wait for some time after it gets started. It is starting meshing. It may take some time depending on your processor of the laptop and your system. So as you can observe, the geometry which we made has been successfully imported in this meshing part. Now, if you take a look at this panel over here, you have different sections like the geometry import. It basically imports the geometry, whatever you made in the previous section, like the geometry section. Here it is our geometry. It defines the geometry. Under the geometry, we have the part which includes the three different sections. That is the fluid domain, top wall, and the bottom wall, respectively. So you can just minimize this one. Yes, minimize this one. In the material section, it defines the material which you are using for this one and this one. You can define the separate materials for each of them. After the material system, this is the coordinate system. Here, as you can see, uh, this is the starting of the coordinate system. That is, this point is 0 0, and as we move on, the x increases over here, and as we move on like this, the y increases over here. So this is a very important thing which you have to keep in mind further in the analysis part, because we have to deal with we will be making various plots of the temperature and the pressure. There you have to choose one start point and one end point, which will be giving the variations as you want. So never mind, we can see that in the further analysis part. After the coordinate system, go to the meshing. This is the important part which we will be selecting in the meshing. Now here, if you can see, the element size is 101.12 millimeter. We are just going to give it 10 10 millimeters, I guess, 10 millimeters. Now just generate the mesh after selecting the element size. It will take some time. After generating the mesh, as you can observe that this whole geometry has been now divided into a number of small cubes depending on the element size. The element size is 10 mm, so it will divide the whole geometry into small elements of 10 mm cubes, which will be further used in the uh, analysis part. Now our meshing is done. If you want, you can also do a very fine mesh by reducing this uh, number a bit, but I am using 10 mm because of my system constraints. Actually, if you minimize this dimension a lot, it takes a lot of processor and RAM memories to actually divide the geometry into a number of elements. So I am just keeping it 10 mm. After that, we need to define the separate names for each section. Like this one is the inlet section, this one is the outlet section, this one is the top wall, this one is the bottom wall. So we just need to enter different names for this one. So here, yeah, as you can see, you have different type of selection. Like this one is a vertex selection, this is a edge selection, it will select the edge on the geometry. This one is a face selection, it will select a face of the given geometry. This is a volume or body selection, it will create a different volume from the body. So first we are bothered with the edge selection. Just click on the edge, this one, and click it over here, this part, and right click over here, so you'll get different options. And in this one, create name selection, it will create a name for that particular edge. Create a name selection, click over there, and just name it as inlet, because this is the inlet of our flow. From here the flow or the fluid will be entering, and flow from here the fluid will be leaving the channel. So this is our inlet. Click on OK. After this, we have given the inlet section name. Then similarly, we will be giving the name for the outlet section also. In the outlet section also, so just click over the edge selection, click the outlet, this section, this edge over here. Right click on it and create name selection and name it as outlet. This is outlet. So click OK over it. So it will create the outlet. So this is our outlet, and this one is our inlet. From here the fluid will be entering, from here the fluid will be leaving. After that, you select the face meshing. You select the face meshing. Yeah, face. Sorry, not meshing. Face selection. Now select this face and right click and name it as top wall. Top wall. Hit OK. Similarly, do for the bottom wall. Create name selection and name it as bottom wall. Bottom wall. Hit OK. So this is the top wall. This is the bottom wall. Top wall and bottom wall, and we are dealing with constant heat flux, like constant heat flux at the wall. So it means that the top wall will be having some heat flux and some temperature at this particular edge, and the bottom wall will also be having some heat flux and some temperature at this particular edge. So we have to name them separately as well. So click on the edge selection, click this edge and right click and create name selection and name it as top, name it as simply top. So hit OK, and then similarly for the bottom part, right click and create name selection and name it as bottom. heater. So these are the various names that we have given to the geometry. This is the bottom wall, top wall, inlet and outlet. Okay. So, and this is the meshing part. All of this is completely done. Now just close this window as well after ensuring all of this that all of the steps have been completed or not. After that, close this window. So as you can observe, we have done the geometry part, we have done the meshing part, but here you can observe a thunderbolt sign. So it means that the mesh or whatever name selection we have done, it is not updated in this part. So to update it, right click on this mesh and click on update. So it will take some time to update the parameters that we have given and set the values to the model. So wait for some time. Okay, so now as you can observe, the mesh and geometry both are being updated. Now go to the setup section, double click. So it will start the fluent base. This is the fluid launcher in which we will be analyzing or basically doing the computational fluid dynamics part. In this section, select the double precision and increase the number of solver processor if you want, depending on your system requirements and the system properties. I have chosen 3 and then hit start. So it will take some time to start the fluent base. Just wait for some time. And just wait for some time. It is actually loading the geometry. It may take some time. It may also take less time depending on your system. Okay, so the geometry has been imported. As you can see, this is our geometry. This is the solid domain. This is the fluid domain. This is the solid domain again. This is the inlet part, and this is the outlet part, right? So now, as we are dealing with the uh, heat transfer problem as well as fluid flow problem. So we have to include the energy equation as well as the fluid parameter, like the whether the fluid is laminar flow or turbulent flow. Depending on that, we have to input the parameters. So just here we'll be having steady flow as steady flow, and we are not including the effect of gravity. This is a pressure based type solver. So after that, go to the models, double click, and here we'll get the energy off. So double click on it and click on the energy equation. And okay, so it will turn on the energy equation. Now it means that it will also be taking into consideration the energies due to the temperature variation. After the energy equation, go to the viscous, double click on it, and select the laminar flow. As we are dealing with laminar flow, yeah, hit on OK. So this is laminar flow. So this section is done. Now in the materials, if you want, you can modify. Like in my case, I am going to use my fluid as water liquid. Water liquid. So double click on the fluid. It will So it will open this separate window where you can create or edit your materials on your wish. So by default, it is set to air. I am going to use water liquid for my analysis part. So just go to the Fluent database. After it turns on here, you have to search for water liquid. Water liquid. It will occur at the last section of this drop-down menu. Select the water liquid and all the parameters of the water like its density, specific heat, thermal conductivity, viscosity are given in this particular chart. So just copy it and close it and just close this one as well. So as you can observe, your water liquid has already been added to this fluid database. So we have air and we have water liquid as well. So you can choose any one of it as you wish. I'm choosing the water liquid for my analysis part, and for the solid, that is the solid domain. For both the solid domain, I'm using the aluminium part, which is by default already set in the fluid base. I'm already selecting the aluminum. So just minimize this. We have assigned our materials as well. Now go to the boundary conditions. In the boundary condition, we have the inlet, we have the outlet, and we have the bottom. That is the bottom section and the top wall, and then we have the bottom wall and the top wall, right? So we will be giving the various parameters based on it. Now we have first we'll giving the inlet, like we'll be giving the fluid velocity, and fluid velocity here I am choosing 0.05 meter per second. This is the fluid velocity, and temperature is set to 300 by default. So click on apply. After applying, hit on close. At the outlet, if you can see the outlet, okay, at the outlet, give everything as already been set as default, so hit on close. Now on the wall, top wall and bottom wall, in the top wall, hit on edit. So in the top wall section, we have to give a constant heat flux. So I'll be giving a heat flux of 20 watt per meter square, and selecting the temperature as 300 Kelvin by default. uh, for the top For the top wall, I have given the heat flux as 20 watt per meter square, and the temperature as 300 Kelvin. Just click on apply and close. And similarly, for the bottom wall also, edit. On the bottom wall also, you can give the heat flux as 20, and the temperature is set to 300. 300, you can set it like 90 Kelvin. Hit on apply and close. So the bottom wall and the top wall are already done. And for the top and bottom, like at the top section and the top part, I will be giving the temperature. So here we have the temperature as 300 Kelvin by default. So hit on apply and close. Similarly for the bottom wall, click on edit. The Here we have the constant heat flux and the temperature is 300. Click on apply and close. After applying the boundary condition, just move on to uh, initialization. It will initialize all the boundary condition and all the parameter which you have set. So click on initialize button. So yeah, after initialization, you go to the run calculation, double click on it and set the number of iteration as 1000. After setting the number of iteration, just hit on calculate. So it will take some time to calculate the various parameters. Just wait for some time. Okay, so the calculation part is also completed. Now, if you want to see some contours, like double click on the contours, go to the results in the graphics, and there you will get the contour. In the contours of select the temperature or the velocity, basically velocity, and save and display. So it will show us the variation of the velocity at the inlet and at the outlet. At the inlet, as you can observe, the velocity magnitude is this much, and at the outlet section, the velocity magnitude is this much, and how the velocity is varying with the wall portion. How the velocity is basically varying with the wall portion. You can observe from it. Similarly, instead of velocity, if you want to see the temperature variation, save and display. So this is the temperature variation. At the top section, you have the 300 Kelvin, and at the bottom section, you have the 290 Kelvin. This is the variation. This is the variation of the temperature. So hit close over here. And similarly, if you want to plot the various x and y plot for the temperature and the pressure and density variations, so just go to the plots over here. You will be getting the xy plot. Double click on that xy plot, and you will get this. So on the y-axis, I am selecting the temperature, and on the x-axis, I am selecting the direction vector. And I'll be choosing one new surface, or basically here I'll be selecting one line. The starting point will be 0, 0, and the ending point will be your point, sorry, 2 meters and 0. So this will create a line. So just select the line over there. So line, this one, line 16. Line 16 is already been selected. Okay, so line 16, and then save and plot. So this is the variation in the temperature as you move from the inlet to the outlet. So at the inlet section, you can observe the temperature is 300 Kelvin. So as we keep on moving, the temperature decreases till 1 meter, and after that it again increases. It again increases little bit. So if you similarly want to see the pressure variation, so the pressure varies something like this. At the inlet part, you have one pressure of 3 into 10 to the power minus 3 and pascals. And as we keep on increasing, keep on moving towards the outlet section, the pressure keep on decreasing. Pressure keep on decreasing. Similarly, the velocity also. The velocity part at the inlet. Okay, so this is the velocity variation with the flow. So that's all for this video.